Chapter 6, the normal distributions and the other continuous distributions. So for continuous probability distributions, there are three common types. The first type of continuous distribution is normal distributions. And for normal distribution, what we have is basically a bell-shaped and a symmetric. Second one is uniform distributions. Uniform distribution is basically when we have a rectangular shape, rectangular distribution. And the reason we have a rectangular distribution is because each value has the same probability of being selected. So every value between the smallest and largest is equally likely. And last one is your exponential distribution. Exponential distribution is when we have a right tail. So right tail is basically when we have right skewed. And the concept that you need to know is that when we're looking for probability, probability is basically the area under the curve. And when we're looking at the normal distribution shape, when we change the mean, when we shift the mu, what that does is that it shifts the curve to the left or the right. So there's a shift in the curve when we're changing the mean. And when we're changing the standard deviation, what we're doing is we're increasing or decreasing the spread of the curve. We're making it flatter or making it steeper. So that's what the difference between changing the mean and changing the standard deviations. Changing the mean will shift the curve, while changing the standard deviation will change the shape of the distributions. And in this chapter, there are two formulas that you need to know. The first formula is probability equals to norm dot this. And the second formula that you need to know is x equals to norm dot inv. So those are the formula that we're going to use in Excel. And the key concept that you need to know with these two formula is that it will give you the probability to the left of x. And that's just how Excel works. Excel only finds the probability to the left of x using the norm dot this formula. And if you're looking for x, using the norm dot inv, it will only take the probability to the left of x. The next concept is standardized normal distributions. And basically what standardized normal distribution means is that now instead of having the mean equals to mu, what we have is that the mean equals to 0. So that's why we have the mean equals to 0 in the diagram. So instead of having the mu, what we have is that the mean equals to 0. We standardize it to the mean equals to 0. And then the standard deviation is now we have a standard deviation of 1. And for the standard deviation, instead of having it called sigma, now we have one standard deviation just equals to 1. And that's your standard deviations. We're standardizing the mean equals to 0. And we're standardizing one standard deviation just equals to 1. And what we're calling it is the z distribution. So it's the standardized normal distribution, which is your z. So instead of calling it x, we're standardizing it. So now our standardized z distributions, we have your mean equals to 0, and then we have the mu equals to 1. And any value above the mean, we have a positive z value. So anything to the right of the 0, anything to the right of the mean, we have a positive z value. And anything below the mean, we have a negative z value. So anything to the left of the mean, we have a negative z value. And that's what the standardized normal distribution does. And the next concept is the empirical rule. We have went through that in chapter 3. And basically what it states is that for normal distributions, when we have the mean plus minus one standard deviation, that covers 68%. So when we have the mean and we plus minus one standard deviation, so in the green area, that probability is 68%. When we take the mean plus minus two standard deviations, that gives us the 95%. So when we take the mean and then we plus minus two standard deviations, so the green plus the blue area, so that whole area here is 95% probability. And the last one is your mean plus minus 3 standard deviation, that will give you the 99.7%. So when we take the mean and we plus minus 3 standard deviations, so green area plus blue area plus purple area, these three area, so that's mean plus minus 3 standard deviation, that probability is 99.7%. So the area under the curve here is 99.7%.